Alright, we should now be live. Hello everyone, and welcome to today's live stream. Technically the second one of the day, because the first one, the audio was not working, which is very embarrassing. But anyway, here we are with the witness effect that I was working on for the past couple of days, or, just on and off. But now I've applied it to the actual model, which is really, really cool. It worked out much better. Well, I would say about as well as I was expecting. I had to do quite a few edits to the model to make it work, just because there were some topology issues, which I guess I could get into a little bit later. But yeah, let's start out with this effect. Let's make an abridged version of the previous stream where the audio was all messed up. That was so funny. Alright, so first of all, this is a geometry nodes effect rather than a shader effect because right now in Blender 4.1, the real-time renderer does not have shader displacement, which in 4.2 it does, but unfortunately the 4.2 render Eevee Next is, it doesn't look that good at the moment, so I'm waiting until it becomes as good as the current version of Eevee. So, first of all, we have the model, and then we take the UV map. Most of this can be done in the shader editor, if you have vertex displacement in the future. So we have the model, and then we take the UV map, and then we move it up at different increments, and we give it different scales for the faces and the clouds. Now, technically, you could just connect this into there and there, but if I wanted to use these attributes in the shader for, like, coloring it, using the same textures, it's the options there. So, with that, we then go and get the height maps for the displacement. So this is the faces that I got from, well, not I got. This model was given to me by one of my commenters, which is really considerate of them. I really like looking at game models and seeing all the tricks that they pull to make it work, because I try to incorporate those kinds of tricks into my projects, which is very cool. But yeah, so here's the height map. It's good. Maybe if I were to try to do like a cinematic render, I would try to get a very high quality render of the faces, which I guess I could do. With the previous version, I had a head model and then I rendered out, I think it was either a 1K or 2K texture, maybe I went higher. But if I were to make this quote-unquote cinematic quality instead of game quality, I would try to get this head scattered around and get as high of a resolution height map as possible. And then, I would subdivide this even more, which I guess I should showcase a bit of that. This model is not the original. I had to make a grid and then kind of shrink wrap it to the original plume, because the previous one, and I can showcase this by looking at the actual mesh over here, was it? Yeah, the actual mesh for this is a little bit iffy. It seems like they optimize it for a few viewing angles because, or the person that I got from did some editing to it, either or. But it seems like on this side they wanted high resolution, while on this side they wanted less. Which unfortunately, I can't really subdivide this properly. And also right here it gave a lot of artifacts just due to how stretched the faces were. So I had to go and basically reshape a grid to this to make sure it was all even. Which was a bit more of a hassle than I wanted to, because I wanted to transfer all the data, like the UV maps and all that, almost as close as I could. But I haven't transferred over the weight paints, the vertex groups yet, which I could because I have the UV map that matches, but that would be a little bit of a hassle because the bones are named in, I think, encryption. The naming is a little bit, I think it was messed up on the export. But yeah, there's that, all the faces right there. And then for the clouds, which is combined into the same texture, was from the game is just a standard texture like that is just scrolling. I did not want to use that one because it looked a bit, low res and stuff like that. Well, in the cinematic, it was, I'm assuming, an actual smoke simulation. So I'm using 3D noise because that is the fastest way of approximating that. So we have the clouds UV, and then I add to the Z-axis over a bit of time. Right here we can see that just gets fed into a noise texture, too detailed, nothing too fancy. I could go higher, but that would not look good. And then this could be a map range, but I just multiply add because it was a little more convenient. But yeah, then that happens. And then what we do is use a smooth maximum to combine the two, or kind of overlay them a little bit. I can actually showcase this, where if we move the clouds down, you can't see them, because, well, yeah, if the clouds go too high, then they overtake the faces, but if they're not, then that happens. So basically, that happens, and then the smooth part blends between them a little bit, just enough so that they feel more like a volume rather than just clipping meshes, if that makes sense. So after that, I mapped the range again to bring it down, so we can see that part right there. That's pretty cool. Again, most of this could be done, pretty much all of it can be done inside of the shader editor if you can do vertex displacement in the shader. Again, in cycles, or EV Next. I really want EV Next to be good enough for that, or let me specify that. I want it to look as good as regular Eevee, but yeah. Because right now, there's a big difference in the conversion process, which does not look too great. So yeah, and then next up is blending. So we have the texture, but how do we make it blend into the scalp and all that cool stuff? It's a bit more complicated than I would like, but here is how it goes. So here I have one gradient just going up for like the general displacement. Then I have a different one for like the very precise scalp displacement right there. So those two just lead to a gradient like this. And then what I do over here is I blend between a clamped version of the gradient. So this one has a maximum of 0, which min and max, the naming is a bit weird because this clamps the bottom of it, so it can't go below 0. So you do that so that the parts cannot clip through the head, which as we can see there, that would happen on some occasions, but I do want it to go out by a bit. So with that together, you multiply the normal times that, and then put that into the offset, and then boom! You have the kind of volumetric cloud effect, which looks really, really good thanks to subsurface scattering. So let me go and showcase the actual shader side of this. And I'll also read the chat. Let's see. I tried vertex displacement with Eevee Next, and it wasn't the best result, and using geonodes worked out in my tests. Yeah, Eevee Next, it still needs some time to cook. Mainly just some conversion parts are a bit broken, like with the kind of... I tried out these light speed effects, but I thought they were a bit too visually noisy for the render. That like the Traveler's Beam during that one cinematic. Yeah, but these just would not convert properly, which is very, very weird. Oh yeah, I should also mention, just as a disclaimer, I do not play Destiny. I see the cinematics, and I know a bit of the lore thanks to a few of my friends. I think that's really cool, and I want to make some more stuff, some more, you know, stuff that's kind of, I guess, cinematic ready or game ready, whatever you want to call it. But I want to try out more of that kind of stuff, which in this case, it's pretty easy because, again, most of the work's done for me by just having the actual asset here. But then I can make the quality a little bit better because I'm not running on a game budget. I can use 3D noise for the clouds. I can make it look however I want. And it's also cool just trying to replicate effects as closely as I can using the limited computer power that I have, because again, I'm not running a Threadripper or anything. I'm not doing a massive Houdini simulation for voxelized smoke simulation. But this is fairly similar to how you would do it in a game, and it would be a ton faster because of, once again, vertex displacement, and the subdivisions would all be applied. But yeah, for the fast mode, it works out pretty well. I guess that's, yeah. If I were to apply it, I think it would probably run in semi-real time. Let's take a look. Yeah, it's almost real time. As real time as Eevee. Okay, let's go and lower that back down. So we have that, and in the shader. So I have the cloud subsurface scattering thing, which looks pretty good in and of itself. But then I blend that to transparency up top here, which has to be dithered, which I'm not the biggest fan of, because, again, Eevee noise is not great, which is one of the reasons why I'm not the biggest fan of Eevee Next in its current state, because everything is noisy. All the shadows are noisy. Everything's noisy. While in regular Eevee, the shadows are jittered, which leads to some inaccuracies, and they won't be as smooth in some scenarios, but they look good even at a low sample rate, which in Eevee Next, it feels a little more like Cycles, where it's like, oh, you gotta crank the samples up. But yeah, So we have that, and the transparency is looking like that. Then I have the kind of skin shader so that it blends into there, which I do have a little bit of alpha to go and mix between the two, just because one side effect of this was that the normals, in the actual model, the geometry normals are bent to the head, so this would blend perfectly, at least visually. Unfortunately, geometry nodes cannot set normals at the moment, and the modifiers didn't work out too well, so I'm just doing a little, just blend with a gradient, which you can see it right there. I could make it a little bit better, but at the moment, that's as good as I wanted to make it. And there is a bit of a color difference, but in here, you can't really see the color difference all too much. I should probably go and fix that. But yeah, there's that, subsurface scattering between the head and that. I try to make it as close as possible, the skin color and all that cool stuff. So yeah, just trying to match those things for the blending, again with gradients just based on the UV map. There and that one. Standard stuff, nothing too complex. Which actually makes me think, I think probably in the game, well, they have to do this in the game because I'm assuming that hashed alphas don't work well. I'm assuming that the headpiece here is alpha blended in the actual game, just because, and that's why it's a separate mesh, or at least separate material, so that the fallback looks okay. Oh, and I should also mention that the seam is right there, but you usually don't see it. I think in the original model, the seam was there as well. I'm not sure if the vertices were split, but I could combine these and that would be gone. So just keep that in mind. But then again, with vertex shaders, sometimes they split. I would need to look into that. But yeah, it works very, very well. So for the kind of Mystique panels here, which some of the people who made the cinematic, they did a little Houdini talk. And when they were talking about this effect, they said that I think one of the directors said, or someone referenced the actual Mystique effect, which is really funny to see that effect keep coming around in the kind of VFX sphere. But yeah, for this part, it's again another vertex shader done in geometry nodes, again because we can't in the regular shader editor. But in this case, it takes, in this part, the model that I received, quite a bit of this was already done. I just made a few edits cleaning it up and optimizing it. Then the clouds were basically all me, because I've had a previous version that I went and reshaped and made it a bit better. So this part is not, it was not done by me. I just cleaned it up, and also for the plates right there. But mostly this is just, we have a gradient, which we separate this part so that that's the gradient, and then you add to it, use a cosine so that you get these waves, which look pretty cool. I wonder, are these per... No, they're not per face, interesting. But then you multiply that to get that, and then you multiply it by a vertex color, which in this case it's just this gradient. You multiply it, then you multiply the normal by that, and then when you put that into the offset, you get this kind of really cool tiling effect, which I really like. Same kind of thing is happening with these here, but instead of displacing the normal, they're just displacing it positionally. So you take the gradient here, gradient here, then you displace them using the gradients and all that, more sine waves, but just moving them in space, which means that these are warping a little bit, but I think this is completely fine for a game. If you want to be really, really technical about it, you could be like, oh, I can store the center positions in the vertex color, then I can make them rotate using math, but if it works, it works. Again, it's supposed to run in a game, so you're on a limited budget. Fortunately, in Blender, we have a basically unlimited budget because none of the renders are real time. Eevee takes a minimum of 1 second per frame, which is a really horrible frame rate if you want to do a game. But we have a much higher budget for render time, so that's really cool. So yeah, beyond that, is there anything else to go over specifically? Oh, the cape. In the cinematics, I noticed that the cape would leave a kind of ghosting effect like this, where maybe it's a bit hard to... There we go, that's a bit better. It would trail behind and then would fade from up to down. It would just go away. And there would typically be 3, but from this angle, I was just like, oh, you just need 1. That's good enough. And that's like that. For the surface details, which I wonder if they have any of these in-game and they just didn't transfer over to this model. But by default, they look a little bit simple. But in the cinematic, they had some micro details, which I tried to add just with, white noise just to make it as cheap as possible. Which again, we have a huge budget. This could render at 5 frames a second or 5 seconds per frame. And it would still be like, yeah, that's pretty normal for a high quality Eevee render. Again, Eevee is semi-real-time, not a real-time renderer. It's basically only real-time in the viewport at one sample. Because again, you can see the shadows aren't final and, while you're moving it. But there you have that, and that normal displacement, again, linear light, so that goes in the positive and negative directions. I could just do this with matte so that it all, you don't have to do the conversions, but it's fine. And that is that. Anything else? I'm trying to see where the previous stream left off when I realized it was a bit broken. Yeah, for the eyes, I did a little bit of noise displacement on here, and the gradient is done procedurally, because the eye texture I don't think transferred over. For the face here, it's very interesting how this texture is laid out, because again, this is the game one. Let me go and isolate that part. So here, I'm assuming this is the metallic, roughness, and then AO maps. Which, come to think of it, I did not multiply this by the AO. I really should. But a very common thing in games is that they like packing grayscale textures into one colored texture, which you've probably seen quite a bit as I've been going on with all this. But you have, I'm assuming this is metallic, roughness, and then AO. Which, one thing that I wanted to do, if I were to make a close-up of this, is to, in the cinematic, I forget what this is called, this part of the body, but that is black, and then the black fades into there, kind of like ink. So I would go and change that part of the texture if I were to go and make it high quality. Or if I were to try to go cinematic quality, which I am not qualified to make assets of cinematic quality. At least models. Procedural stuff, that's another story. That we will talk about another time. But yeah. There we go, and that part's pretty good. The eyes, I did a little bit of special stuff here to tamp the IOR level because I found that looked just a little bit better. Oh, another thing, if you're wondering what this part back here is, I used a little bit of parallax. This is completely impractical, but I have a parallax set up right here. Oh, and it's not even properly working because the UV map's not right. I really wish that, actually, wait, I could do that with vector math. When I made this, I just used the UV tangent, but nowadays I could just make I could get the UV tangent outside of this, and it would probably be accurate enough to do the parallax. But anyway, all this does is make it look like there's a sphere, like, behind the eye, so if I were to disable it, it would look like, oh, it's just on that part of the eye. So you could just go and move the geometry back, and it would work just fine. But I was like, you know what, let me just try to do a little bit of that. So when you have this, it makes it look a little bit like, the kind of glass part right there. I don't know, could look cool. Completely unnecessary, though. Like, you probably wouldn't even notice the difference at this range. So that is that part, and 18 minutes, not bad. So, the next part for today's actual effect, after that very long explanation, is I want to do the arm ghosting, which I know people were very interested in. Oh, I should also mention, the cloud effect, my version of the cloud effect, is currently up on my Gumroad page. Just go and check that out. It has the test version because, of course, I cannot just distribute the model. I don't know the legality of all that. But just the cloud part of the effect that I made is available on my Gumroad page for free if you would like to take a look at it. And then, yeah, okay, so the arm effect. So, we're getting back to where I was right before the audio issue was discovered. So I'm going to go and animate the arm so that it moves, and then I will chop off the arm, and then make it so that the arm ghosts. I'll chop off a part of it and then just have that for the copies, because that will need its own material. But this will be a fairly simple effect to make, so I hope you're all ready. This uses quaternions, which I think I want to use. Yeah, let's just go with Oilers. Quaternions are not needed. They're complex, and I do not want to deal with any more complexity than what is specifically needed for today. Just making sure that's all of that. Yeah, I won't move the fingers, so I think this is all good. Okay. So I'll just have this right here. Yeah, let's go and move this up. I'll make it so that over 20 or so frames, it'll move from the still version, like maybe from the side. Because the witness, it seems that witness does not do any big movements. It's only gracefully floating across the screen and then gracefully lifting up a hand to slice something into, about 100 pieces or so. You know, as you do. But yeah, maybe we'll do that. Oh yeah, no, that's a good pose as well. You know, just that. Yeah, I can see the witness doing that. So yeah, like that. And then I could use my secret weapon when it comes to procedural animation, which is the Wiggle Bone add-on. So I could go and make it so that there's, you know, a lot of dampening and all that. We can change the amplitude for the rotation. So that we can make it look like there. Well, that's not looking great. Let's go and change that. Now let's set that to be like that. Okay, maybe not like that. No, we need higher dampening, lower stiffness. This just helps when it's like, oh, I do not have time to animate this for 2 hours. So I'm just gonna go and I'm going to go and do it procedurally because I like procedural math. Oh yeah, that seems good enough for that part, and then I could just go and copy over to here. This is the Wiggle Bones add-on, which has been very useful when needing to do physically based animation. I hope that one day we'll be able to do this with nodes, because that would be very, very good. I would be able to do so much, make so many cool rigs with that. But unfortunately, it seems like it'll be years before that happens. The devs have, not the geometry node devs, separate devs have mentioned rigging nodes, but it seems like, let's also add it for the hand. It seems like that is much farther into the future once geometry nodes is, yeah, no, that could pretty well. Let's set this to 0.05. Oh yeah, no, that's looking pretty good. I do want to turn up the dampening on this one. So there, and then... Oh yeah, see, you get some nice follow through, because again, if you want to make something realistic, well, do the realistic physics. But yeah, it's been a long time since I've gotten to properly animate instead of using these, procedural, I guess, physically based, versions. I do want to make like really nice stylized animation, hand done, but unfortunately time has been my enemy with most of this. But yeah, that's looking pretty good. Well, it could be a little bit better. I'll lower that by a little bit. I want more drag. Maybe 0.5 was correct. Yeah, the dampening, well, let me try this out. Okay, so that, and then... Yeah, no, that's a bit too much. Edit the values. Well, I could add in gravity, but who wants to do gravity? Yeah, that's good enough for that. I may edit it in the future, but that's the beauty of procedural effects. You can't always just go and tweak them later on. So let's go back to the Geometry Nodes tab, which is the tab that I do like 99% of all my work nowadays. Let's go and save this, and I'm going to go and copy this model and put it into the ARM, what would we call this? ARM duplicates, ARM fade, ghosts. Yeah, ghosts. There we go. Now let's go and collapse these other ones so that I can see all this pretty well. And now what I'm going to do is I'm going to go and chop off the arm. Maybe both. Yeah, let's go and chop off both arms. Oh, I really want to tries to quads this and then just eliminate it, but I really... Like, I know these models have to be triangulated to be exported. Or imported, export, you know, all that stuff. But it's like, oh, the tries to quads thing never quite works the way it should. So the conversion, it's a destructive process, which is so sad. Actually, you know what? Let's try it anyway. Yep, that's a little bit rough. But reapplying it should be okay. I just want to go... Oh, shoot. No, let's try to get one clean one clean loop. Yikes. Okay. Okay, yeah, let's do it manually. Oh, let's just go and separate it. Yeah, no, that's not bad. What am I complaining about? I could always just chop off that part of the arm, because we don't really need the shoulder. Should I do that? Just chop off... Yeah. Yeah, we don't need all that. So I can just go and select all this. There we go. Do this faster, but anyway. Maybe I could go and get the UV seams and that would be better. Actually, yeah, let's go and take a look at the UV map for this. Ah, right. There's a lot of interesting stuff happening here. Yeah, no, I could... Whoa. Oh, I have the relax tool selected. I could just go and do that. So here... Come on, buddy. Where is... Yeah, there we go. So that's that. Okay, so that's the UV map for there. I want to select you. Oh, and that just works. Huh, that's very nice. There we go. So all that annoying, like, oh, what are we going to select? You know, wasn't even necessary. Okay, so now let's go back to the Geometry Nodes tab. Now we have 2 disembodied arms, which is exactly what we need. So these will be arms, and then I'm going to duplicate this material because this will be a blended effect, because I don't want to deal with hashed noise. It is very, as the name suggests, very, very noisy, and I do not want to deal with it. And for this effect, you would probably do this in compositing, usually. Let's turn off show back face. Yeah, that'll be good. That will be good. Okay, now it's time for the actual geometry node effect. Arm ghosts, which this part is fairly simple. Fairly simple. We just need to make duplicates of these arms that exist for a few frames, but we could also make it so that they kind of try traveling to the current frame to give it that kind of more accurate look to the cinematic. So let's go and do that. We need a simulation zone, as per usual. The good thing is this effect is rather straightforward. And we don't even need to convert to instances because these will be moving. So here we go. Let's go and join some geometry. I think we want... Yeah, no, that'll be good. We want that to be like that, so that part's good. So now we should see, in just 2 clicks, there we go. We have... Wait, why was that, Huh. Why did it do that? Oh well, maybe you need to ignore the first frame? That's odd. There should be no... Maybe that's just an update issue. Yeah, I won't worry about that. Oh no, wait, that's probably Wigglebones doing that. No, wait. Well, I'm not going to worry about that right now. Okay, let's just get the data that we need. So we need to store an age value, which is pretty much all we need. Named attribute age, we're just going to increment that by 1 every single frame. There we go, so we have that. So now we should see, if we look at this named attribute at the end, that they should start off with 1. Right here, let me go and use a greater than node so that we can see this. There we go. We can see that the ones that are older have a lower gradient. Just with this, since it goes in increments of 1, we can't see it in color space. So there we go. Yeah, we can see that now. Actually, I'm going to make it so that the age happens before the new ones are joined, so that the ones that are joined have an age value of 0. There we go. So, yeah, that's a bit better. So there we go. Now that we have that, that works out pretty well. And now we want to make it so that some will delete over time, so that, you know, it doesn't become super laggy. Again, I'm assuming if you're doing this in a game, like, games do this. Well, there have been a few games that have this kind of ghosting effect on various characters and stuff, but I would assume all of this would be done on the GPU, so it's lightning fast. Again, if you're moving a ton of pieces of geometry, you want to do that on the GPU, because, again, the CPU does everything sequentially, and that is not fast. So here we should see that these will delete after 15 frames, which is pretty good. So, that's that part. Let's add in the shader bit before we start doing some other cool stuff. So here, the shader is a little bit messy. I did not, I need to organize it. But now let's just get that age value as an attribute. And we should see if we go and take a look at this. Wow, gradients! Those look very good. Then we want to use a map range node to go and mix between an alpha of 1 and an alpha of 0. Then we want to set, the actual age range that we want. So now if we click on this, we should see that they're fading. Maybe not the best fade. Maybe they need to be maybe it needs to be a bit more abrupt. I'll say 10 frames. There we go, that's pretty good. Maybe we need to ignore the first frame. Well, we'll see if it clips. We will see. Okay, let's go and move these up. There we go. Let's see, alpha fade. There we go. Yep, that's pretty good. I could also add in a smoother step. So, oh yeah, that looks a bit better. Yeah, there we go. I think the witness model just has multiple bones and multiple copies of the arms for simplicity. Oh yeah, that... If it's like 3 bones, then yeah, or no, 3 copies, then you want to do that. And maybe there's this procedural way in... Well, I'm assuming yes, in game engines anything is possible, if you have enough knowledge. There's a way to like dynamically copy an object and then displace the armature animation, so that would be much faster, because in this case, with geometry nodes, we can't copy an object and the bones and all that and then just make it work. We have to do it on the geometry level, because again, it's geometry nodes. But yeah, that should be okay. I could also go... Yeah, let's make it so we have our age part over here. Now I'm going to make it so that every so often, the parts will show up. Because, and this is a thing that differs from games. Here we have a locked frame rate, so we get 1 copy per frame. In video games, the frame rate differs all the time, so you don't want it so that 1 mesh spawns in per frame. So doing it as a set amount of copies is the way to go, because things could be very, very bad, very, very bad if you don't do this. But I will use a switch node so that we can use the current scene time frame, and we're just going to go and wrap that. So if it's equal to 0, it will send the mesh through. If not, there won't be anything. Here, let's set that to be between 0 and 1, and I think that needs to be... Yeah, there we go. Okay. So now we have that. So now it looks like there's just a low frame rate. While in reality, we're just including these over time. There we go. Yeah, that's pretty good. Include every... Let's see, every n frame. Yeah, there we go. That's pretty good. Now that we have this set up, I'm going to make it so that there's a little bit of like actual ghost movement. So how are we going to do this? Well, let's go and copy the geo input right here. Oop, come on, delete the frame. So what we're going to do is sample the current position of the moving geometry, which is the input, and then mix that with the frozen copied geometry. Now, is this accurate? No. It'll be a linear interpolation instead of interpolating the bones. Again, we don't have access to the bones in Blender. So we will just be mixing between position 1 and position 2. So let's use a set position node to set the position. So we want this, we want the current position, and we're going to mix this with the position from this geometry. Again, this geometry moves in real time. This one, actually, wait a second, why are the normals a bit messed up? Maybe that's just the model. These ones do not move, they're frozen in time. So this is very simple. We can use a sample index to get data from that geometry, and then we just go and put it on the other stuff based on the index. So position based on that, and we want this to be the index. So it takes the index of the vertices, and it compares, oh, are the vertices the same between this one and this one? Okay, let's transfer the data from 1 to 1. And the vertice index doesn't have to match exactly for the operation to work, but it needs to be accurate to be accurate. The indices could mismatch, and you could do some really cool stuff with that if you have if you plan for it. But if you want to copy data from one object to a copy of the object, you need it to be just that. So that's pretty good right there. Let me move this back so that we can have this all in one nice little thing right here. One nice unit. I like making the nodes units. The upside with nodes versus code is that it's very easy to understand where the data is going. Just very easily. Now, that's also the downside of nodes. Everything becomes a giant web. But fortunately, with geometry nodes, we can do these nice units, and we can store named attributes when we need to. So it's a nice mixture of the two. Okay, so right now we should see with that mixture, something has gone horribly wrong. Uh-oh. We good, bud? Okay, what is going on? Let me just check that. For some reason, it's reading this as nothing. Did I do something? Oh! I would like to report that I was just a little bit dumb. So, for the indices to match, we need to make it so that the indices actually match. Since we're not doing this with instances, the problem is that... Actually, should I do this with... I may rework this to use instances for simplicity, but for the time being, let's keep it all as real geometry. Let's not overcomplicate it. What we do need to do, because I did not plan for this, but again, this actually ties into what I said before. The indices don't have to match 1 to 1 in terms of like the geometry count and then the index count. You can remap some data. So let's go and store the index data on the geometry so that when it's joined, the indices will be shifted, but we have the accurate indice as a named attribute, so we can reference it. So, apologies if that was a bad explanation. Basically, we're storing it so that even if the literal vertex indices change in this geometry, because geometry is being joined, here, it will remember it once we've referenced the named attribute. So this will be vertex ID, so VID. We'll connect that into there. So now, and this will work, I can guarantee it. Now when we do this, we need to reference that VID, because again, it causes a matching, an accurately matching pair of indices so that we can get the data correctly. So this will be ghost movements. There we go. So now we should see right here. See, it's working exactly as I planned. Also, I just noticed something. It's clipping. So we need to do show backface and backface culling. There we go. So we can have multiple layers of the alpha. I should mention that alpha blending can be very annoying, but just because of how it's calculated, but it's fine. Let's set this to a reasonable value, which I think 0.05. No, that's not good. Here, let's go and show the actual arms so that we can see this in context. So here, no, that's not looking great. Okay, let's go. I've done this before, and I've made it look good before, so I can do it again, if need be. Oh, that's what's wrong. It's not taking in the wiggle bones animation. So this is something that I like to call dependency graph hell. I'm assuming the wiggle bones add-on was made before Blender 2.8. So there was a dependency graph change. So here it doesn't look like it's taking into account the actual animation of the wobbled bones. So I'm going to have to go and disable that or bake it out. Let's go and turn that off for now. And maybe it was updated, but in this case, simulation nodes does not seem to be working with it. So in this case, I'm going to go and bake the animation. In this case, it should be fine. Okay, so bake action. We want this on the bones, and this is only selected bones. We want to visual king. Yeah, let's do that. We want to clean curves, overwrite current action. I don't think we need that. That should be everything. So we want to bake it out, and then in this case, we want to turn off wiggle bones, which means that we should see it seems to be working. Yeah, wait, where's the animation? Hello? Oh, okay, the animation is there, but for some reason... Oh, but because this one was acting as if it was Interesting. Never mind. But yeah, now that that's all baked out, we should see that it is following. So now I just need to make it so that it actually looks correct. Yeah, something's a bit off. What is it, though? Is it appearing too often? Do we need it every 3 frames? I also don't know why that first... What's happening right there? Yeah, something's not right. I could make it so that it... I could use the age value to blend between different, mixture values. So that just needs to be honed in. Again, it's not an exact duplicate, and I think the cinematic... Was the cinematic an exact duplicate of all that? Maybe I can extend the lifetime. Let's have a lot of copies so that I can then play around with the alpha map range here. So let's set this to 30 and see everything. So yeah, that is way too slow, but this makes it look way too fast. It's like close. Maybe the animation is just not fast enough, potentially? Yeah, I'll just have to hone. Maybe it's like that. I need to think about this a little bit. Maybe I could just use the age to make it mix, and that could work, but I've done this before, but it has been a few days, so I don't remember exactly how I did it. I've been too busy with other cool stuff, which I will need to show off. Maybe when we hit 1 hour. So here I'll make it so that I'll start off with no offset, and then it's helping a bit. Let's show the original mesh. I'm assuming that the materials are missing because the cache is not quite in sync yet. I mean, it's almost working. Close, but not quite. Still looking too much like, low frame rate instead of it actually working. That's looking a bit better. Okay. Maybe I need to make it so that the mix happens and then it fades as if it were losing velocity. I'm not going to add an actual velocity because since this is, again, a linear interpolation instead of copied bones and all that. Yeah, no, that looks better. That looks significantly better. Okay, the max is 30 frames. Let me turn that down to 15 and see how that looks. Okay, no, let's use 30 frames because that looks good enough. So here we have that, and then it does that. So one thing I do want to get rid of is... Yeah, that's one thing I can do. I want to make it so that the first duplicate, which is accurate... well, actually, is it? Is it reading the current frame? Is there a clipping version? Nope, the mesh is not clipping precisely. Except when that's happening. So why... Okay. So the caching means that if the cache is invalid, the materials don't transfer. So if there is a bake, the materials are okay. Which I think you can change that in the settings. Yeah, there we go. So that's a lot better. We now have the witness's arm moving and there being a decent ghost following effect. There we go. We can turn that up by a bit more. There, we'll have it at 0.5. So now we should get that feeling of it's like, I don't know, separating a bit as it's moving. There we go. I should make the animation a lot more, but, you know, I would have to make something a bit better. Like the witness's animation, from what I've seen in the cinematic, it's very, there's not a lot of wobble, it's very direct. It's like, duh, duh. I moved my hand along with that sound that I made, but you cannot see that. So I apologize for that. So here, like, it would be a little, it would be faster, which I can make the animation faster. I don't need to rebake it to just do a simple, speed up the bone animation. Let's go into the actual animation tab, because for some reason, that stuff's happening there. So wait, I want this to be S.8. So here we can make this a bit faster. That's just like that. Okay. Yeah, that's good enough. And if I wanted to make this even better, I would make the body contribute to it, you know, do actual animation. But I don't have time for that, unfortunately. We would be here for probably 30 minutes to an hour of me being like, okay, let's add in, you know, some nice swiping motion, well, like arcing motions and all that. But yeah. So that's good for now. So I could do a shot of that, but yeah. I don't plan on making any, like, cinematics myself. I just want to get to that, like, that kind of... I want to get the looks mostly right, and then just be like, okay, that's good enough. Because I have enough time to do the effects, not enough to extrapolate and make something, like, over 5 seconds long. There we go. Yeah, I'd say that's good enough for now. The fading could be better. You could always use the power node. Let's go over to here. You could use a power node to go and change the fall off of these. So if it's 0.5, I think this will make it, yeah, like that. If you set it to 2, the fading will become probably a little bit better. It's all a matter of personal preference and, you know, what the shot requires. There we go. So that looks like that. Power of 2, I think it looks the best. Again, get that motion, but the actual ghosting. Also, here we're seeing the crimes of alpha blend. Like, it just does not know the meaning of this object is in front of the other. But for most parts, it should be fine. And again, you could always just separate that part for compositing, as you would do normally. You would just have all those duplicates, and then you would go and make them fade in with all that. So again, invalid cache equals it turning up without any material. Materials have plagued... Well, material bugs with simulation nodes have plagued it since the beginning. In 3.6, materials were just straight up removed. Which was... a little history behind that. It was removed 2 weeks before the beta or the release. I forget which one. But when I realized it, which I think I realized on a live stream, I was like, oh no. I wonder if that's a bug. Backface calling, that is currently enabled. It's just a result of... Alpha Blend usually operates on a per object basis for, oh, which one's in front, which one's in back. So usually when it's stuff like this, it tries to figure it out, but quite often it does not resolve. And also in this case, I think that's a solid version. Actually, no, that's just the other... Yeah, here we can see it's having trouble because the alpha over there is kind of connecting to the actual mesh and all that. Or not connecting, but you kind of know what I mean. Also, another thing, I'm not sure if this is just an export issue, but there's actual seams, like dark seams, on the bake. On the witness bake. Which usually, I only see that happen because of... Blender's baking system, I think, didn't update correctly with the denoiser. So when you use the denoiser and the kind of infill, or at least, I think in 3.6 when I last did it, it would leave these dark parts everywhere, which was not fun. That's why I was looking into using the Ray Portal node to make a better baking system. A faster baking system where you could bake everything at once and then you're just good. But I will say, you should use an add-on for baking. Like Blender's default baking, it's not good. You can only do one at a time, and it's loaded with quite a few errors just because it's old. So I would recommend get an add-on for baking or another program. Like there are, well, if you want convenience, get an add-on. If you want like industry standard accuracy, well, actually, if you're baking procedural textures, then it needs to be inside Blender. So get a good add-on. I'm sure there are good free ones out there and probably even better paid ones in regards to baking. But yeah, don't use Blender's default baking. Save yourself the trouble. Because it's yeah, it's not fun. I'm looking forward to when we can do baking using the GPU and all that. Without needing add-ons, so that we could do it in just default Blender. You can just have a blend file where you just open it. Doesn't matter what version of Blender you open, or after a certain time, after a certain point. and it'll just work. You can send it to someone and say, hey, here's a baking thing, and it just works. I'm hoping to do that with the Ray Portal node, where you just copy an object into your scene, click the render button, and then you get all the outputs. Which, it's close to that point, but currently only the normals are having issues. But eventually, we'll get to that. Eventually. But yeah, that is the effect, and we're almost at an hour. We're making good time. But that's basically the effect. That's all I wanted to do for today. You know, it's very subtle, but, you know, I just wanted to make the kinds of effects. It didn't take too long. A few glitches again because of the cache. And yeah, anything else that I should go over? If you have any questions about the setup, please let me know. Yeah,